Hello learners, hope that you are keeping well. Today it's revision, okay, the revision, and it's based on geomorphology. Now I am going to use the 2019 paper as you guys have requested to me, okay. So we're going to use the DBE NSC November 2019 paper, okay. So thank you DBE for this paper. All right, and again, I am going to say the same thing at the beginning of each revision lesson. And I'm going to emphasize it on this one again. It's about strategies. It's about getting into the mind of the examiners, how they think, the structure of the paper, the resources and how they link to the question, and the little tips and hints that we get from the resources in order to answer the questions. It's a length of the questions, the mark allocations. And once again, I'm saying, if we get tested, like for instance, on a meander in this paper or whatever, you understand, and then suddenly a waterfall comes out, okay? It's not that, problem, I only revised on these ones. No, it's about strategies, because if you learn to apply your information to various questions, you can take the same questions and apply it to something else. So it's not about going over papers. Yes, we'd like to go over all questions, and then try in my PowerPoint presentations over the year. I have been putting questions at the end. So it's good to go over every section or every section and go questions over it. But sometimes you'll get a section that maybe you didn't cover a question on it, but you can use the same strategies of application. This is geography. It's not difficult. If you can apply your stuff to different resources, different questions, you will do well. Okay, so I know I'm going to say it, and I'm going to say it again and again and again. All right, so let's look at how and the strategies and how this paper is approached with regards to geomorphology. Once again, we're noticing a trend in climate in this paper and geomorphology, that we don't always get the resource. Okay, we just get some questions, but then we visualize and we apply our information in our heads that we applied when we were studying in order to answer the questions. Once again, learners, I'm not going to go through where there's a lot of answers in the paper. I'm not going to go through all the options. I'm going through strategies and use a few examples in there. Okay, so this is a multiple choice question, all right? And it says here, you've got 4 options, A to D. You must choose the correct one, and then you write it in your book by writing the number and the letter. And again, I'm stating, please stick to that. Don't change it. These are the rules. Okay, let's start looking at the questions now. All right, a cross profile. Can you see it's testing your knowledge? You know you've done a cross profile, okay, and a longitudinal profile. Cross from bank to bank, all right, longitudinal from source to mouth. So cross is from bank to bank. Go over all my 4 options. I'm already visualizing. Before I even look at the options, I'm looking at the concept. What is it? All right, and it makes my answer easier. Source to mouth? No. Concave, convex? You understand? No. Bank to bank? Yes. Width to depth? Okay, let's look at it. Can I? If I look here, the shape of the river valley. It's not talking about width and depth. Okay, so my answer can only be bank to bank. This is known as a distractor. If I didn't see this word, I may make a mistake. So you will get distractors in there, like source to mouth, is a distractor. Because if you don't know the difference between your profiles, longitudinal and cross, you've got a bit of a problem or a challenge there. Okay, can you see how it uses that? Okay, then it says the shape of the valley in the upper course. Now you've done it. Remember, you did your thing, and it starts to erode there. It's turbulent flow. It's cutting in, so your valley is deeper. It gets a bit wider here, and it gets very wide there because of deposition. So can you see? You don't guess answers. You can work them out. Right? Similar to maths. That's the only thing that deals with all the figures there. Okay, so the answer was C there. Now, let's look at it here. The shape in the upper course, yeah, okay, is V-shaped, all right? Now, maybe sometimes it says a wider V, smaller V, but we got V-shaped. It's wide, no. It's gentle, no. It's U-shaped, no. All right? So I went through all 4 options, and then I say, no, it has to be the first one. Okay, sometimes say V-shaped, sometimes it will be narrow V-shaped, steep sides, nothing else matches. It's A. All right, deposition process is the dominant process in the what of the river. All right, you've learned it's in the lower course. So let's see what the answer is. Upper, middle, lower. That's easy, eh? It gives you the 4 options. You need to have studied and applied your work. So that becomes lower course, okay, which is C. All right, of course the second one was A and the third one was C. All right, the volume of water in the middle course of the river is likely to increase. Okay, it's talking about the volume. Now, yes, you've learned that there's more lateral erosion in the middle course. You understand it's a big type of erosion there. So sometimes if you don't read that it's referring to the volume, you may just jump for this. Can you see it's important to read what the question wants? Okay, so it can't be lateral erosion. It's not dealing with the volume. Tributaries joining the river, yes. In the upper course, there's less tributaries. You understand? But as you go down, you get more tributaries. That seems an option. Downward erosion, no. No tributaries joining, that's false. So therefore, tributaries joining the river is my most accurate answer from there. We're working it out. Let's look at this. Rapids are likely to develop in the, okay, you will get rapids everywhere, but they're more common in where? You understand? And you've learned that it's in the upper course. So let's look at it here. Lower, middle, and lower. Can you see? The examiner now is adding options there. Okay, middle and lower. No, that can't be. Nothing there. Upper course, yes. Upper course and lower course, no. Okay, so I've got upper course. So sometimes they can give you options. Don't just look at the first word and assume that it is correct. Right, now let's go to the next one. The stream flow in the upper course, and you learned it's starting to cut here, eh? So it's rough flow, all right? It's turbulent. Let's look at it down here. Layered, laminar, I don't know where's layered, but I'm going to put it to check whether you know your work. Laminar, smooth is laminar. It can't be. Can you see it? And then, of course, it's turbulent. Okay? The Oxbow Lake can be formed from what in the lower course of the river? Now be careful. All right? Will it form from a slip-off slope, which is the gentle slope? No, it's a feature. Okay. Will it form from a cut-off slope? No, not just the slope. It has a whole feature. It has to cut through a big feature. Okay. Meander loop, Makes sense. But I see meander is here. Okay, so two places, but watch. That's a meander loop. And this is a meander scar where it's dried out. You're not going to fully get a lake. You understand? So the answer would be loop. Can you see it? Now, this question I'm looking at down here, learners, the processes that a river undergoes from the upper course to the lower course. Bit of a challenge, eh? Bit of a challenge here. Now, what do we do here? Let's take it. We do get erosion everywhere. We do get a certain amount of transportation, deposition. So how would I answer this? All right. Let's look at it this way. We look at the major processes that occur, because we're going to get processes everywhere. Okay, let's look at the major processes. Now we know the river is cutting. Okay, first, there's a lot of vertical erosion in the upper course. Then, of course, we will get erosion in the middle course. But there'll also be a lot of transportation due to the volume of water. And we know the dominant activity in the lower course is deposition. So that's how we work out to get the most correct answer. Okay, in terms of how we approach this sort of question, it may be a challenge here. I always like to use the word challenge, but we can still work through the challenge. So I would go with this one: erosion, transportation, and deposition. And I'd like to look at it. Yes, it's A, erosion, transportation, and deposition. So I'm looking at the main processes. Yet everywhere it happens, but where's the main process? Okay, right. So you can see it's not difficult, learners, but you don't just take an answer. Everything is worked out in here. From your knowledge, from your application, from your vision of what you learned, and you can work this out. Okay, let's go with this. River capture, also known as stream piracy. Okay, we know when one river captures the headwaters of another river, that is river capture. Now we want to know, what do we see in the diagram? All right, let's look at it. We see there's a stream J here. Okay, it's joining in there. That's stream J. We see a stream K here. All right, and it's moving towards this J. Okay, so we're looking now, we're studying and looking. All right, this tells us direction of flow of streams, stream channel, and we're showing headward erosion happening. Oh, whoa. So this is headward erosion, eh? It's moving backward there into the upper part of it, it's eroding upwards. That is why it's headwards. Okay, there's a scale here. Okay, I notice. Right. Now let's look at B. What has happened here, learners? Okay, B has actually taken this water, this headwaters is gone. Can you see it is dried out? Okay, sorry, I apologize. This area is dried out. Okay, I've just got a phone ringing here. Okay, if lucky I got it on silent so it doesn't disturb us. Okay, so this water has gone. It seems to have dried out. All right, and here we notice this headwaters. Okay, now I'm correcting myself. Sorry, phone calls are not good. Therefore, must switch off your cell phones, eh? When you're answering the papers. Don't take it into the room also. Can be a irregularity. Keep it away. And I should learn the same. Okay, so let's look at it here. This river was flowing this way. There's a direction. And this headwater now has been captured by K. Can you see it? By K. Now the river is drying out. Can you see it? Okay. Gap is forming there, all right, in that area. Okay, is there anything else? Yes, of course, the volume of water going towards K now is greater. Okay, it's greater. Okay, there's the elbow here. They're asking us for that. Okay, this would be your misfit stream. Okay, a wind gap. Okay, captured stream. Okay, all these things come through my head now. So this diagram may be very or different to the one you've done in class, but you can still, if you learn how to apply your information, you will be able to work things out on this diagram. Now, I'm sure, as I say, I'm not looking at this, I just made the slides and I said I want to work it with you. Okay, so we can enjoy it together. All right, so let's look at the questions. Define the term river capture. Examiners always like it. Hey, and please, although it's 1 times 1, this is the only case where you put a full explanation for it. Hey, don't forget. All right, it's not just giving away. It must be full. Look at here. When one river captures or intercepts one of those words, the headwaters of another river, or when a more energetic river captures a less energetic. I like this one. When one river, of course, which is more energetic, captures the headwaters of another river. Okay, when one more energetic river captures the headwaters of another. I like that one. Not that the other ones are wrong, but I like that one. It gives you a full description and you can visualize it. Okay, let's look at this. Describe the erosion associated with the process of river capture. That's in sketch A. All right, we know what is happening here. Can you see it here? The examiner has even written it there. Can you see it? Interpreting your diagrams makes it easier. And look at the answer now. Headward. Of course, the word backward erosion is also accepted. But why write it? It's in the resource. All right. A description was given also. It erodes upstream. Because the question just says, describe the erosion. All right. Okay, so maybe it's eroding upwards, makes more sense, all right, because you're describing the erosion. But even headward tells you it's moving towards the source. Okay, so headward, backward. All right, so the examiner accepted the description, which seems more appropriate, but also accepted the type of erosion that's happening, headward, backward. All right, let's look at this. Identify features L and M. Let's look at it here. Sorry, let's go back here. L is the elbow of capture. Can you see it? M is the wind gap. Be careful. Because what we noticed that learners were writing misfit stream. But it's not on the misfit stream. It's between the misfit stream and the elbow. So it is the wind gap. Can you see how we're working it out? We have to be careful. They're easy. So elbow of capture, wind gap. All right. Let's look at the next question. Match the terms capture stream. And can you see, you need to know now. Captured stream, capture stream gains the water. And of course, misfit stream, the water is lost. Okay. The volume is gone down. Okay. Let's look at it. K, gaining the water because it's taking it away from here. Can you see it? So it's the capture stream. All right. J has lost the water. It's the misfit stream. Can you see it? All right. It's all simple application. All right. Let's look further. What is a watershed? You know, it's a high-lying area separating 2 different drainage basins. A high-lying area. Don't forget that, eh? Right. Like the Drakensberg separates the Tugela River from the Vaal River. High-lying area. Okay, that separates 2, something like that. And there's separating the rivers that come through. Okay, or if you got it like that, then your rivers could flow this way and this way. Okay, but it's a high-lying area. Okay, now let's go to the next question. How can the process of river capture cause the watershed to change position? Again, you visualize. You understand? If you find that if the position, one is steeper, one is more gentle, and if the river erodes, you understand? Edward, what's going to happen? It's going to erode the watershed. And now the watershed sits there. All this has been removed. You've done that in your theory. Now look at the answer. All right. Lowering of the watershed. Okay. Let's look at the question. How can the process cause the watershed to change? But not how. It's how. All right. And if I look at this, headward movement retreats horizontally. I like that one because each time you're getting headward erosion, you're getting a movement of the watershed. I like that one, learners. All right, because it actually describes, it actually states how can the process do it. I like that answer. All right, but the examiners have also said a description of lowering the watershed. Okay, lowering the watershed, which is true, because as it gets eroded, it does lower the watershed. Okay, let's look at the next question. What effect will river capture have on the volume of water in K? Let's look at K again. We know K was the captor stream. It captured the water. So what will happen to its volume? It will increase. All working out these simple applications, working them out, it will increase. So when I look at this, all right, you can see it will increase the volume of water in this stream or stream K. All right, but I worked it out. Can you see how the questions are also linked? Like, for instance, if you look at this, the examiner asked you which one is a captor and a misfit stream. You worked it out. And therefore, when you look at this answer, you understand. You already got it. You don't have to think much. So sometimes you find a linkage between the questions, eh? Can you see it? It's linked to a certain extent that you get a little clue from that one, which comes down and you'll be able to answer another question. Okay. Now, what can local farming community around stream J, and let me get my little highlighter, J do to continue the daily activities after river capture has taken place? Okay, we know river capture takes millions of years and the process is slow, right? So of course there could be some challenges on that. But how do we answer this question? First, we look at J, right? We know J lost water. That's how we answer it. We don't start looking at other challenges that it takes time to have a river capture, but at that time people would have adjusted. Okay, we look at what the question wants and how we answer it. Can you see the importance of strategies? We don't start debating issues while we're writing an exam. We look at how can we best answer the question. Okay, so when we look at this question, we know J has lost water. Can you see it? So it's going to have a shortage of water. All right. How would we overcome that? You've done that already. Over many years, you've done that. And I want to show it to you. They would have to access other sources of water like JoJo tanks. You know that, the water issue. You even covered parts of it in grade 11. You understand? So you know all those things. And basically, it's simple answers. Can you see? Harvesting rainwater. Same thing, collecting water. Transport water from other areas, water projects. You understand? Make use of wind pumps and not windmills, eh? Wind pumps or boreholes to access groundwater. Now, it's all that you have done. Can you see? Next one, build dams, storage dams, small farm storage dams. Now, all these answers you know. but it's taken into the relevance of river capture, making that one river lose water, River J. You understand? It's getting less water now. And how would you sort the water problem out? So don't get shocked if it's related just to river capture. It's the same thing about shortage of water in an area, and answers there in context with river capture. So it's not difficult, learners, not difficult whatsoever. Can you see now? That is what I'm saying. No matter which question or which section you get, and even by chance you didn't even revise a question on that section, you will be able to answer if you get into the mindset of the exam papers and the mindset of properly applying in order to understand. Okay. Let's look at this. Catchment and river management. You've done it, eh? Catchment area and how you manage it. You've done the importances of it. You've done the negative impacts that it can have. Let's look at what this question is actually highlighting here, or what this question will be highlighting for that. We look down here, we see settlement, okay? And we see seepage going in. All right, because lots of concrete, etc. So there is a certain amount of seepage, but what seepage is there? We don't know. It could be a pollution. Okay, it could just be saying water penetrating, but we're already ready for that. It shows you runoff. Obviously, runoff will be great because we have lots of buildings and concrete. Okay, let's go on. It shows industries. Wastewater being pumped out from the industries, pollution there. We see cultivated land, all right. Of course, removal of natural vegetation, all right. We see eroded soil and sediment. Erosion has increased, all right. I don't see this nicely, but there's a windmill, it seems there. So sometimes there may not be much clarity, or there may not be a certain amount of clarity. Sometimes it does happen. Maybe in the real one, it's just showing clearly. Maybe my one is a bit off. Okay, but I can see like a wind, looks like something there, like a farmhouse or something. Okay, sometimes, but you will be able to work it out when you look at the questions. All right, there's an orchard here, natural vegetation removed. Okay. Then we're talking about groundwater being discharged into streams. Okay, so as this thing is seeping in, maybe all this, even this waste, etc., is going into the ground, isn't it? So all this groundwater is being discharged into streams. There could be a possibility of pollution that's going into streams. And you know, aquatic or water ecosystems are actually easily, they're very sensitive and they can be destroyed, or it just could be water going in. Okay, but we're working it out. And of course, there's seepage here. If it's a farmhouse, it could be fertilizers, etc., that's been pumped into the ground if it's negative. Okay, so we worked out. Can you see what we see here? Full. And in fact, I also looked at this reference here. The reference actually states water pollution. Can you see it? So even in certain extent, in certain cases at least, even your reference can give you a little hint, eh? Water pollution, eh? Okay, so let's go. What is the main source of wastewater? And if I look here, it's the industries. Can you see it? A simple question. We can't lose those marks, learners. We can't. These are the ones that we can fly through straight from there. And let's look at the answer. Industries. Okay, let's look at the next question. Discuss how the removal of natural vegetation for human activities increased eroded soil and sediments in river. Okay, of course, you know, when you remove vegetation, what happens to the runoff? It becomes greater. It erodes the soil. You understand? So runoff is your main factor. And you did the factors. affecting runoff and infiltration. All we're doing it now is putting it into a specific scenario regarding our resource that we have here. So the lack of natural vegetation will increase runoff, and obviously if runoff is increased, there will be more erosion, and the sediments and whatever will get deposited in the river. All right, let's look at the next one. Explain how runoff from both settlements and cultivated land decreases the quality of water in the river. Nice, interesting question. But what you need to know, it talks about settlement and cultivated land. And I go back to my sketch and check, is there different labeling? Yes, there are industries there, but there is the word settlement and cultivated land. The specific reference in a sketch. I know settlements can include everything, but we need to put it into context of the resource that you have. Can you see the difference, learners? We can't just put general answers here and talk about the industries, etc. We're talking about the settlement and the cultivated land. That makes the difference in answering this. Okay, so let's go and look at it. All right, can you see? Specific to settlement. Now, these may not be shown here, but you know what's associated with a settlement. All right, you've learned that all. If there was clearly written sewage, you understand, etc., then you will write exactly what's there. Here, nothing is written there. It just says settlement and it shows seepage. So I can write all the right answers that are related to the settlement in terms of pollution, etc. So untreated sewage from the settlements end up there in the river, polluting the river. Can you see it causing disease? Domestic wastewater that just goes in, you understand, after you wash your dishes and whatever, you understand, is released into the drainage system, decreasing the quality of water. Grey water from dust and oil from roads, because that's also part of the settlement. Can you see? Pollutes the river system. Can you see what I'm saying here, learners? As I say, I'm not going to go to all options. But now you're right, there's nothing specific in the resource. So you can go, as they say, normally I use old phrase, you can go to town writing down things that you know about that, but in context to the settlement. Let's go to this. Now, if I go back, it just says cultivated land. It doesn't give anything more, but you know what happens with cultivated land. Can you see? So you can give your possible ones there now. There's nothing written there. Can you see? And what do I write now? Fertilizers used from farms washed into rivers causing eutrophication, all right, killing all those life there, etc. Okay. Pesticides used for crops washed into the river, polluting them. You understand? Polluting the river. Okay. Soil erosion makes water murky. Okay. Because now the crops have been, although they're planting, but the natural vegetation has been removed. There could be gaps between the crops, etc., which will allow for erosion. All right. So can you see your answers? Okay, is simple based on your general thing that you learn, because there's no specific information there. If it was written fertilizers, then you had to write about fertilizers. Okay, and they will tell you evidence from the source. Okay, right, 164 in a paragraph approximately 8 lines, and I want to emphasize this 8 lines. Learners, you don't have to stick to 8 lines, eh? Remember, some of your writing is big, huge, you understand? And some of your writing is tiny, all right? But please write legibly, eh? All right, so it makes it easier for the markers, etc., to interpret what you say. Okay, not that they can't, they're used to marking, but try to write as legibly as possible. Okay, so of course your number of lines will differ, it's just a guide. Discuss why sustainable river management is important for all sectors of the economy. For all sectors, primary, secondary, etc. Why is sustainable river management that it goes over a long period of time? You don't just use it now, it maintains it for the future. You understand? Why is it important? Now, again, I know I'm emphasizing it in all my videos on revision. Get that out of your head, learners. I'll just do the 1.62, 1.63, and maybe there and I'll get my marks. These questions are too difficult. And not necessary, learners. Not necessarily. You understand? As again, I'm saying there could be higher order questions, but the level of difficulty sometimes may not. All you needed to get was the sustainable river management. And the concept sustainable has been taught to you for years and years, and you know it. All right. So, and then other important thing is all sectors, and you've done the sectors, economic sectors, etc., in your geography. By that stage, you'll have covered all the things. You understand? That would be important. And you also see a linkage here between the sectors and river management. Okay? Good. So you can link them. That's why the application comes out well. Okay? And you know now the contribution of water in all those things. Look at here. Sustainable measures, river management strategies, access to water for future generations. That's an importance already. Just describing this. Can you see it? Sustainable. You need water for future generations. South Africa's water is scarce, and the country has a low unreliable rainfall. So we need to save the water. Better quality of crops will be produced with higher yields. If you have good water supply, crops that need water, basically all crops do, at certain times some need more, will grow better. Most industries need a good supply of function for productivity, cooling of the furnaces, cleaning up. You understand, water is used so many places. All right, water is necessary for the production of products, example, soft drinks, sweets. You need water to produce. Can you see we're covering so many things? All right, and of course, if you have good crops, you have higher exports, more profits. Can you see how it's being related to all the different sectors, isn't it? Can you see? And that is what is needed. Okay, the examiners here allowed for any sort of 4 here, right? But did not specify that you have to write for each sector. But I say if you come across sometime a question, put one relevance for each sector. All right. So, but it's easy. I see the examiners gave you the effects of unsustainable, which is correct. They did the correct thing. All right. Because you have to look at both ways. Because the question says, why is it important? Because if you don't have it, this happens. Can you see it? So they even went on unsustainable river management. It increases purification costs. Isn't that relevant? Because now if it's unsustainable, you have to spend more purifying water. It increases waterborne diseases. Therefore, workforce is unhealthy. They can't work well because they get sick. All right. Acid water stunts plant growth. Can you see, with all the chemicals coming in, etc., from industries, etc., the plant growth doesn't go well. Okay? Contaminated water poses a health hazard. Polluted water will affect rivers and the fishing industry. Okay? Can you see? So it's the other way around. And sometimes, you see these words, acid water stunts growth. Do I have to learn all that? Remember, you're giving a certain number of options. And if you've got 4 options, or 5, I would say, then you've got enough, you've learned enough. You don't have to learn 20,000. You understand? On each thing, you understand whether it's social, environmental, whatever. If you know 4 to 5, and you can put it into context, you're fine, because that's the most anybody would ask you is 4. 4 times 2, 8. All right? So it's simple things that you can look at. All right? Note these things here. Candidates refer to both sustainable and unsustainable. They cannot do the same fact. You can do a sustainable and unsustainable, but you can't repeat the same thing. You understand? If you say it actually excess clean or fresh water for future generations, and then you say here it does not excess, it loses water for future generations, then you're basically repeating. So if you're going to talk about sustainable and unsustainable, you must make sure they are different facts. Okay, let's go on. That covers our question there. Let's check. Can you see? I'm not lying. I'm doing this with you and enjoying it. Okay, let's go to this one. And you notice here also the pattern, learners. It's showing you that you don't get the resource, then your visualization comes in. All right, here again it says you've got a set of terminology, read the instructions, and then you've got a description down here, and you must match the description with the terminology, put the number down for the description, and write the correct term next to it. All right, so let's look at this. A point where the river enters the sea. Okay, you know you've done that, and there's the sea here. Okay, and you know what's the answers. This is the mouth of the river. River mouth. Can you see it? Worked it out. Water that has infiltrated the soil. You know, infiltrated, gone into the ground. Groundwater. An area drained by a main river and its tributaries. There it is there. All right. This, you must have a good knowledge of your concepts. And it's 7 out of 7 or 8 out of 8. If you don't have that concept, knowledge, and know how to apply it, you've got a problem. But you should score total in this. Drainage basin. A point where the river originates. Can you see the important now? These words, enters the sea, originates, tells you where it starts, where the river starts. And of course, that is the river source. The upper level of a saturated zone. Change the words a little. You understand? But where saturation, the upper level of the water table sometimes is described at, but that's where the water has been saturated. So all it does is add the saturated zone, you understand, or not the upper level. Okay, so that's the water table. Okay, and this is perfectly fine of the saturated zone. Okay, and all this is found here. Can you see? Water flowing over land, it has, after it has rained. You know, water flowing over land, you already worked it out. It's surface runoff, not run out. Point where tributaries meet the main river, you know, as they meet, like that, there's the main river, and there's the tributary coming in, you know it's a confluence. Now, what am I doing here, learners? I must do one more step, and maybe I need to remind you. I look at this point where river enters the sea. That's the river mouth, isn't it? I must look here. Ah, there's it here. Don't just jump here. You know these things, and this confirms that it is correct. You understand? We find nothing else there. Oh, water that has infiltrated the soil. I know that is infiltration. It's groundwater. Okay. Ah, there's it here. Can you see? You confirm. Don't just look at the answers there. You know it in your head. Just go forward with it like that. Okay. Right. Let's go on. Ah, this shows us river profiles. Okay. I know 2 river profiles, the cross and the longitudinal. This is a longitudinal profile. Okay, right. What do I see here? Base level, it's the sea. That's our permanent base level, eh? Once water enters there, that's it, it's permanent. What do I notice here? It's a smooth profile, eh? It seems to be graded, all right? And it's steep at the top, concave in shape, steep at the top, gentle at the bottom. Oh, that's it there. Let me see why they have drawn another profile. Okay, this is a new profile. So this was the original one. Now it's a new profile. It seems like erosion and deposition or whatever has happened. All right. Okay. So look here. I see a dam wall here. Okay. So that creates a bit of an obstruction there. Deposition of sediments now is happening in this dam. Okay. Maybe less water here. I don't know if the examiner is going to test on that. I'm not sure. All right. And there's my permanent base level. So it has been adjusted by man putting a dam wall there. Okay. All right. And therefore, you find it's different. Okay. And this says over time. See, I've explored it, but as I practice, I'm doing it a bit slow now. When I've practiced over the years, I'm gone old now. So I'll do it quickly now. And you practice, you do the same. So let's look at the questions that's been answered. Define the term longitudinal profile. Examiner brings it into perspective that you're dealing with the longitudinal profile. Okay, the side view of a river from the source to the mouth. Okay, side view of the river from the source to the mouth. Whoa, look at the diagram. All right, from the source to the mouth. Okay, then next look at the next question. The shape of the longitudinal profile. The shape of the longitude. It is concave in shape. Okay, accepted here was steep in the upper course, less steep in the middle course, gradual in the lower course. Why did the examiner also? Because it says describe the shape. So you gave a full description like that. If I said steep in the upper course, less steep there, gradual, you understand, would give me a general concave shape. But basically you described it here in that concave shape. Examiners try to give various options as possible so that learners put it in different ways. We can accept answers, or the examiners can accept answers. Identify the ultimate permanent, all right, and temporary base level of erosion in the diagram. Okay, we looked here and we know I'm not going to waste time there, so I can do more work. It's the sea and the dam that created an obstruction. Okay, right, the dam itself. Okay, I know generally you'll be sitting there and saying we did lake, we did rapid, we did that, and we know those natural features. It is creating an obstruction here, right? That can create a base level. Okay, so there are challenges, but look at the diagram and you see a dam wall there. Okay, that's the only thing. There's no lakes, there's no rapids, there's no waterfalls. It's a dam wall. So you write that, don't get into any debates there. That's what's visible. Okay. How will the deposition of sediments influence the capacity of the dam? It sounds quite complicated, eh? The deposition means sediments being deposited in the dam. Yet the answer is very simple. If I keep on putting sediments in here, right, the volume of water will be able to hold less water, isn't it? That's about it. Okay, the deposition of sediments will influence the capacity of the dam. The dam keeps water. So look at the simple answer. All right, it will decrease the capacity or decrease the volume of water. 2 marks. Can you see how simple it is? All right, let's look at the next question. Describe the difference between between the new profile, use the new longitudinal profile and the original longitudinal profile. You saw graded, ungraded, etc. Okay, you've seen it down here. Can you see it? Graded, ungraded. All right. The original profile is graded. It's concave in shape with no temporary base levels. The new longitudinal profile is ungraded and has temporary base levels. Easy, easy, learners. 4 marks. And then your last one, explain the impact of the presence of the dam on erosion and deposition processes. You know it's holding back the water there, there'll be deposition, etc. Okay, but it's specific to erosion and deposition. All right, and show, you see erosion, more erosion upstream as the dam wall has a greater volume of water. Now it'll hold back, isn't it? Erosion temporarily stops at the dam because now deposition and the dam wall stops the flow. Rate of erosion decreases downstream because what happens downstream now? Less water, less erosion. Okay. Deposition, the position of silt in the dam results in less deposition downstream because what happens now? Sediments get caught by the dam wall here, so less deposition will happen downstream, less volume of water also, as I said. All right, and then of course the rate of deposition increases the velocity of water, increases as the velocity of water is reduced downstream. Okay, so two ways of looking at it. One, this will hold back. Two, because the volume has decreased, it doesn't have so much energy, all right, to carry its load. It will start to deposit its load here. What do you notice about this, learners? Don't be scared. You studied a thing, and if it makes sense, you will get alternate answers in the memo so that it does not disadvantage any learner. All right, learners, that's the important thing. Okay. Let's look at one more. Whoa, the floodplain. All right, fluvial landforms. We know this is the floodplain found in the lower course. All right, and we look here. There's a meander here. Okay, a meander is showing here. We've also seen, they're showing us descriptions here. That's a slip-off slope. That on this side is a cut-off slope. Okay, we see some Oxbow lakes down here. Okay, we see the cut-off slope. We see a natural levee forming here. And now we're working in our mind, whoa, this natural levee is when we had the river like this. You understand? And then there's deposition after flooding. And what happens is, as it gets deposited, banks are raised. It cuts down flooding in these areas. Okay, but on the other hand, it reduces sediments from coming out. Can you see all these things I'm going through? All right, here too also I learned that the slip-off slope and the cut-off slope where the river moves, you understand, is a cut-off, it's eroding, making it steeper. And here there's deposition on the other side. You understand, making it more gentle. All right, they are part of the meander. I fooled around with so many things, Right, learners, I'm going to go a little quicker because I want to keep to my hour. You know, I talk a lot, All right, but it's necessary. So let's look at this. Figure 2.6 is based on fluvial landforms in the lower course of the river. Examiners told you that already, but of course, you are intelligent. You worked out that it's in the lower course. All right, so name fluvial feature A. Okay, if I look here, it shows a meander. This may be pointing to a slope of that meander, which is undercut slope. So let's look at what comes across. The meander loop is there. Let's look at what comes across in the memo, learners. They say undercut slope, meander loop, and they said except meander. Okay, so can you see, learners, if I know it's not really sure, the examiners or the memo caters and gives you alternatives. All right, let's look at the next question. Give a reason for the formation of feature A. Right, let's look at it. What do they put here? If it's an undercut slope, you know already the water is flowing at a faster rate. All right, and there's erosion on the outer bank, creating the steep undercut slope in comparison to the slip-off slope. All right, and you know the meander or meander loop, the lower course is gentle, and what happens? The river starts to wind. Okay, or that becomes more gradual, or reduction in velocity of the river, so it starts to wind. You throw a bucket straight, it's water would force, it's going to go straight. If you let it trickle, it's going to meander, all right, or bend as it moves. Okay, right. As I said, I'm not going to go through all the options. 263, let's look at it down here. Explain why the undercut slope is B. We already worked it out, because that's where it's eroding, etc. All right, therefore it's steeper. Constant undercutting, it's cutting in as the water flows. Remember, if I draw this here, okay, and I draw here, and my river is flowing this way, you understand, it's undercutting or cutting in that slope, and each time it's cutting, it's making it steeper. All right, and there's another option they gave here. Faster moving water on the outer bank removes the eroded material. So there's no deposition, not a limited deposition to make it steep. You understand? To make it gentle as it gets deposited, rather, my apologies, it washes away that. You understand? It washes away that because the water is flowing there and all the deposited material is washed away, or most of it, you understand? And therefore it keeps it steep. Let's look at the last question here. Feature C is a natural levee. Feature C, natural levee. You know, the elevated banks, etc. that we show. All right. It's a natural one where flooding happens. Man can also make levees, When the chance of flooding, he puts those little netting with rocks in it, etc., and raises the riverbank. All right. So this is a natural levee. Right. Why is this fluvial landform commonly found in the lower course of the river? Can you see it's always about that lower course, gentle, and then flooding, etc. You know already when flood happens, the deposition happens. So it's emphasizing that. Why is it in the lower course? Okay, because flooding generally occurs in the lower course. Can you see? You know how the meander or the levee forms, but now it's bringing into context with the lower course. You can see. So therefore, you have to make your answer more related to the lower course. Can you see? So flooding generally occurs in the lower course of the river, and it overflows. The sediments, they are deposited on the banks. That's the main thing about it, So sediments get deposited on the banks and the banks get elevated. But here the question was on the lower course. Yes, it happens. There's more flooding in the lower course. Therefore, more sediments get washed out and get deposited from the river onto the river banks, elevating it. All right. On the lower course, the river gradient is more gentle. Therefore, there's a gentle and deposition occurs, or more deposition occurs. All right. I like the first answer, but look at that. The examiners are nice. They gave you another option in case you missed out certain points, but go with the first option, That's more the correct answer. You'll always find the more correct answer in the first one. Not that the second one is incorrect, but the more appropriate answer is the first option. Most occasions. All right, let's look at the last one here. In a paragraph of approximately 8 lines, and approximately 8 lines, explain the positive and negative impact of levees on farming on the floodplain. Sounds very scientific. Once again, I'm proving this to you. Learners, it's a high order question, but it is not difficult. The positives and negatives of levees with special attention on farming. That's the only thing is brought it into specifically of farming. And learners, you can answer this. This is always my advice. Even if you get 4 out of 8, you answer 2. Even if you get 2 out of 8, you understand. But I want you to get 8 out of 8, obviously. But those learners who think, I'm going to leave out the paragraph questions, you will lose out. You understand? It's very, very important. Okay, look at some of the answers here. On farming, right, on the floodplain. Easy. Positive, it reduces the risk of flooding, isn't it? When the banks become elevated, all right, on both sides, all right. Therefore, less water can go through. It increases the depth of the river because it makes it higher now. Okay, so less flooding, farm loss, and farm equipment. Can you see it? All I did was say it reduces the flooding, right, and less loss of farm equipment. So what I did was I related it to the farming. That's all you need to do. If you just said let's reduce the risk of flooding, you wouldn't get the mark. All right. All you do is the question stated farming. Can you see it? Farming. So you just relate it to farming. If it said something else, you relate it to that. See, it reduces direct runoff, making the river, making more water available for farmer on the floodplain. Because what happens sometimes if this elevated point was here, you understand, was not here, it was just like that, lots of water will come through, they'll run off. So later on, there may be less water, but it creates a storage facility for the farmer to use. Levees prevent fertile soil from the floodplain from being washed into the river. So in here, you got fertile soil. It doesn't get washed because the levee acts as a barrier. Can you see these things? I'm not going to go through all options, learners. I know my hour is almost up there, and I'm sticking to it. Negative reduces deposition of sediments, rich alluvium, fertility of the soil on the farmland. So what happens? Because it gets raised, the rich sediments, alluvium, less comes across. So the farmer needs this to farm because he needs this fertility. You understand, this alluvium, all right, to farm on, but he loses out. Can you see the negative? So therefore reduces fertility of soil on the farmland, reduces access to water for farmers, all right, because sometimes farmers use just the canals to pump the water. Now this elevated may reduce the amount of water. Can you see the positives and the negatives? But in this case, you must have positives and negatives. Learners, as long as you have both, is fine. You can have 3 of one and 1 of the other. It's still fine. 2, 2, 3, 1, as long as you've indicated. So sometimes you say, hey, I only know 1 negative. I know 3 positive. As long as you put the positive and the negative, you are fine. Once again, learners, I do want to emphasize the point that it's about application. All right? You will be able to apply it maybe on certain concepts that maybe the papers allowed you to. Try and do it for all concepts already, or all sections. But sometimes, as very, very important, if you know the technique, the strategies, and all that, you are much more definite of getting a better mark than what you normally get. Okay, so again, I'm emphasizing the point. This 4 times 2 means 4 fully explained points. This tells you the number, and this tells you the length. All right, if it says 1 times 1, remember, if it's a definition, it must be full. Other ones say 1 times 1, identify the feature. Then you'll say it's a Mesa. Or I'm getting back to Mesa now. I do apologize. It's a Meander. All right, because I'm doing 11s and 12s. Okay. Learners, I hope I created some clarity with regards to geomorphology, and you requested the 2019 paper, so I'm doing it, and I'll be doing more sections on this in the future lessons. Keep well, learners. Goodbye.